All right, everybody, here's Mr. Longo, and we're going to talk about combinations today. So, a combination is a selection of R objects from a group of N objects where order does not matter. So, if you think about that, your locker is a lie. You're lied to your locker every time you have to enter something in a certain order. Remember, it's called a permutation, not a combination. So, technically, you don't have a locker combination. You have a locker permutation because the order in which you enter those numbers does matter. So yeah, you should start telling people that you forgot your locker permutation instead of combination. They'll look at you like you're nuts. All right. So, what do we mean by a combination then? So if order doesn't matter, that's like saying that we have three different paintings and they finished in first place, second place, and third place out of a total of 6 paintings. Well, that is an order. First, second, and third does matter. However, what if we were to talk about 3 paintings that are going to be displayed in a gallery from a pool of 6 different paintings? How many combinations can 3 be chosen to be displayed? So here's the thing. You're just displaying. There's no first place, second place, third place. You're just going to hang 3 paintings out of 6 on a wall so people can look at them. So what we would do is use this formula. So when it's combinations, it's n factorial over n minus r factorial times r factorial, because the order doesn't matter. You have a lot more possibilities when order matters. So you could have a first place, or what if that first place painting was actually second place? Or what if that one was actually third place? Or what if it didn't place at all? And you had to ask that question for all 6 paintings. You would have a heck of a lot more possibilities than if it's just like, hey, we're just going to pick 3 of our favorite and hang them up on the wall. It doesn't matter where, doesn't matter which place. It just matters that 3 out of 6 got selected. So to do that, you could use the formula, but the purpose of this is, how are we going to use our graphing calculator to do so? Because we already talked about it with permutations. Now let's do it with combinations. We would just have 6 choose 3. So that means we have 6 options. We're just going to pick 3 of them. And of course, as we said, the order doesn't matter. So we're going to go to math, slide over to probability, and now we see that number 3 is and choose R. So we're actually going to do number 3. So we have 6 to choose from, and we're going to pick 3. And we should get 20. And we do. So we have 20 different possibilities to just select 3 paintings to be hung on a wall. Again, order doesn't matter. So that's what a combination is. It's the order does not matter. There's no first place, second place, third place. There's just, let's hang up 3 paintings. Okay, so the next 2 questions we're going to talk about come from a deck of cards. So we've already talked about the fact that there's 52 cards in a deck, and we have, half of them are red, half are black. There's 4 different suits. There's ace through king. We have face cards, diamond. There's all sorts of different stuff we know about a deck of cards. So here's the thing. If order is not important, how many different 7-card hands are possible if you were playing 7-card poker? So since it doesn't matter, like if your first card you chose was an ace of hearts, or the last card you choose is an ace of hearts, it doesn't matter. You have an ace of hearts somewhere in your hand. So the order of which you select the cards does not matter, because whenever you're playing cards, the first thing you do once you get your hand is organize them in a way that works best for you. So again, the order doesn't matter. So here's the thing. When you're playing poker, and it's a 7-card hand, you have 52 card choices, and you're only going to choose 7. So we should expect a pretty big number here. So again, it's math, slide over to probability, and it's number 3. So we have 52 cards possible to choose from, and we're going to pick 7. And we got a pretty big number. We have 133,784,560 different ways to have a 7-card hand when we're playing poker. Okay, so how many of these hands have all 7 cards of the same suit? So that is extremely complicated because we have to remember that there's only 13 cards of a suit. Now, what you need to do for this is keep in mind that we're only going to do one suit. So let's just pick diamonds, for example. We're going to pick diamonds to start. So for diamonds, there are 13 diamonds, and we're going to choose 7. So if we were to take our calculator and do 13 choose 7, math, probability, number 3, we would have 13 cards, choose 7, and we have 1,716 options for diamonds. But then you have to also consider, you also have that same number for hearts. You also have that same number for clubs. And that same number for spades. So each one of those has 1,716 different combinations. So if we have 4 different suits, we just have to multiply that by 4. And you would end up with 6,864 different ways to have 7 cards of the same suit. 1,716 per suit. Okay? So you have to take into consideration that there's multiple suits. But when you're doing your choices, you only have 13 options in a suit. So the last couple of questions are going to be, do we add, do we subtract, do we multiply? So here's the thing. We're going to take a vacation. And we can visit as many as 7 different cities or 5 different cities and 7 different attractions. So we have a set number of each that we can do. So if we're going to go to exactly 3 cities and 4 different attractions on our trip, how many different trips are possible? Well, since this is broken down into different things, we have 5 possibilities to choose from, and we're going to pick 3 different cities. And since we're going to switch over to attractions, we're going to multiply that by 7 options, choose 4 attractions. Okay, so we just need to use our calculator. 5 choose 3 would give us 10, times 7 choose 4 would give us 35. So we're going to have 350 different types of trips we can take if we, mess them all up and do different things, okay? So that is when you multiply, because we're very specific to how many we want to take for cities and attractions. But what if we were to switch it up a little bit and say that we wanted to just visit any 8 locations, but this is at least, so we're going to do, visit 8 total cities and attractions. That would just be how many different options we have. So we have 12 different options, and we're going to choose a total of 8. So for that, again, here's another trick for you. If you haven't seen this before, second enter will bring up the last thing, and you can just go change that. So we can change that to an 8, and change that to a 12, and we have 495 different options. And that's if you just so you could pick 7 different attractions in only one city, or you can go to 5 different cities and hit up 3 attractions. It doesn't matter, as long as you come up with 8 different things to do. So that's how that comes into play, where we add those 2 together. So that's that with taking a vacation. So now let's go talk about a question where you would use some addition. And this is because we're going to select a total of different options. So we're going to go have some pizza. And we have a list of 6 toppings because cheese is going to come on all of our pizzas. Okay? So we're going to use addition here because we first have to decide how many toppings we want. So what if you just wanted a cheese pizza? So you would have 6 options and you're going to choose 0 because you just want cheese. Plus, what if you wanted only 1 topping? And then again, you're going to see where this is going. What if you wanted 2 toppings? And then what if you wanted 3 toppings? And what if you wanted 4? What if you went all the way up to you want every single topping? You would have to just add all of those up because we're not multiplying because they're not 2 different things. We're just making a pizza. So then you would actually have to find each one of those individually. So 6 choose 0, that does have an option. That's one option. That's cheese only. Plus, and then what if we were to choose 1? So if we were to choose pepperoni or sausage or bacon or peppers, you obviously see you're going to have 6 different choices because you only have 6 options to choose from. So 6 choose 1 is going to give you 6. And then we would need to do 6 choose 2. So we would have 15 different options for 6 choose 2. And then of course you have to go all the way up. So 6 choose 3, you would be at 20. 6 choose 4, you would be back down to 15. 6 choose 5, you only have 6 options because that's pretty much the same as 1 topping because you're only choosing 1 topping to eliminate. So if you're going to choose 5 toppings, that means you're still only choosing 1 topping to not put on it. You like everything except mushrooms. So there's only 6 different things to eliminate. Plus, and of course, there's only one way to choose all 6 toppings. And you would add all of those guys up, and with 6 possible toppings, you have 64 different options of pizza that you can make. So you would actually have to add those all up. So now, what if you wanted to do, I have up to 4 toppings on a deluxe pizza. How many different combinations can you have? So this is an example where you could add if you want to. And since we've already done all of these, 6 choose 0 all the way up to 6 choose 6, you can just say 0, 1, 2, 3, and 4, and you can just add all of those up. So if you wanted to do up to 4 toppings for a deluxe pizza, you would have a grand total of 57. But what if this was a much bigger pool? So what if we were going to do all the way up to 12 toppings? And you could choose up to, say, 10 for a deluxe. You wouldn't want to add every single one of them up. So another thing you could do is take the total and subtract the 2 options you're not allowed. Because you have at up to 4 toppings, which means you can't have 6 choose 6. And you can't have 6 choose 5. So that would be our total of 64 minus 1 minus 6. That would still give you a total of 57 different options. Okay, so you really only use subtraction if it's a shortcut when you take the total and subtract just a couple of them from it. Otherwise, you would have to add them all up, and that would take you more work than just taking the total and subtracting, a couple of them. So that's it for combinations. This is Longo and I'm out. See you, bye.